In today's session, we are going to explore, or we are going to discuss how we get the direction of motion of a particle along a trajectory at a particular time. Now, of course, as this particle along its direction, along its motion, as it's moving, it keeps changing its direction, and its direction is defined by the angle. This is alpha. Alpha so happens to be the angle of projection, but as this particle keeps moving, this alpha keeps changing. It means that the angle here is not the same as the angle here, and the angle right there, that is the angle between the horizontal and the direction where this thing is moving, it keeps changing. So now, if we want to know this angle at a particular time t along this projectile, that is what we mean by direction of motion. We get this direction of motion by analyzing the direction of the velocity of a particle at a particular time t. Now, analyzing the direction of the velocity, for example, let's look at this point. We have this is velocity in the x direction. Here we have velocity in the y direction. And for us to be able to get that angle theta means that we're supposed to analyze the velocity of this particle at that time when it is right here. So if I may draw a vector diagram of this, this is Vx moving in that direction. Then we have Vy moving in this direction. Then we have that velocity in that direction from V to X. Let me call this V. So meaning that if I want to find the direction or the position or the direction of motion here, it means that I want to find this angle. By what angle is this thing or is this particle at that point? At what angle is it traveling? The angle to the horizontal. So it is as simple as finding that. And me finding that means that I am going to use trigonometry. So in this case here, I can use tangent of this angle theta. We know that here, tangent of that angle theta is going to be equal to the opposite, which is Vy, over the adjacent, which is Vx. And getting the angle here of Vy over Vx, I'm able to get the value of angle theta, and that theta so happens to be the direction of that particle at that point. We discussed this earlier when we said, and for us to get this value of theta, we know that our value of Vy is this one, and our value of Vx is right there. So we substitute these expressions right here to be able to get our value of theta. Now, if our value of theta is 0, it means that the particle is at maximum. Because it is at maximum when this theta is 0, it keeps on reducing up to the maximum point when the value of theta is 0. And if our value of theta so happens to be a negative, it simply means that the particle is moving back downwards, and so the value of theta in this case is below the horizontal. When it's below the horizontal, it's a negative value. When the value of theta is above the horizontal, it's a positive value. We shall be using this as we are doing our worked examples in the sessions coming ahead. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.